Identification of organic compounds. Study of mixtures. The mixture should be treated in turn with twice its volume of water, hydrochloric acid, dilute sodium hydroxide, and concentrated sulfuric acid. When sulfuric acid is used, care must be taken to keep the mixture cold. If the mixture is a liquid, it should be treated with solvents in a graduated cylinder. The volume of the liquid should be noted before and after shaking with the solvents. In this way, it can be easily seen whether any of the mixture dissolves. If this occurs, the mixture should be treated with small quantities of the solvent as long as any of it dissolves. Its dissolves, the several solution should be examined separately. The water solution should be carefully distilled. It is tested first with a litmus paper to determine whether an acid or an anion is present. If an acid is present, the solution should be neutralized with sodium hydroxide before distillation. The acid will remain in the flask as a sodium salt, and all volatile substances will pass over. The boiling point should be carefully noted during the whole distillation. If there is evidence of the presence of anything in solution, tests should be applied to the distillate for the classes of substances soluble in water. The extract obtained by treatment with acid should be rendered alkaline, and if a basic substance has been removed, it will be precipitated. It should be separated and tested. The extract obtained with sodium hydroxide is next treated with diluted hydrochloric acid. If an acid or phenol is present, it will be precipitated and is examined. The concentrated sulfuric acid solution is poured very carefully onto twice its volume of cracked ice. Any substance with which is precipitated is washed with a little water, separated and examined. If two substances which belong to the same class of compounds are present in a mixture, it is usually necessary to separate them by fractional distillation. A full record of all tests used should be placed in the notebook. The observed physical properties, melting point, boiling point, or specific gravity of the substance and of the compound prepared from it should be given together with the physical properties as recorded in the reference books. At least we have the appendix that describes the main reaction that has occurred during the book of exercises. The Schiff's reagent, for example, dissolve about 0.2 gram of aniline in a small amount of boiling water, cool, and add 15 centiliters of saturated solution of sulfur dioxide in water and allow the mixture to stand several hours until it becomes colorless or pale yellow. Then dilute to 200 centiliters with water. Reagent should be kept in a well-stoppered bottle of dark glass. Toolner reagent: make an ammoniacal solution of silver nitrate by dissolving 10 grams of the salt in 100 centiliters of a solution of ammonia prepared by mixing equal volumes of concentrated ammonia and water. When ready to make a test, mix a portion of the solution with an equal volume of a 10% equal solution of sodium hydroxide. The test should be made in the cold. The sodium hydroxide should be added immediately before use. On standing or on heating, the mixture so prepared deposits a black explosive precipitate. Filling solution: dissolve 4.6 4 grams of pure crystalline copper sulfate in distilled water and dilute to 1500 centiliters. Dissolve 17 grams of sodium hydroxide and 118 grams of pure Rochelle salt in 400 centiliters of water and dilute to 500 centiliters. The solutions should be kept in separate bottles until used. The filling solution is made by mixing equal volumes of the two solutions. A solution prepared in the way is of such strength that 1 centiliter of it will oxidize 0.005 gram of dextrose. Millon's reagent. Dissolve 10 grams of mercury in 20 centiliters of hot concentrated nitric acid and dilute the resulting solution with 13 centiliters of water. Hopkins gold reagent. In a large flask, place 10 grams of powdered magnesium, cover the latter with distilled water, and add slowly, keeping the mixture cold. 215 centiliters of cold saturated solution of oxalic acid. When the reaction is complete, filter. Make the filtrate slightly acid with acetic acid and dilute to 1 mild centiliters with distilled water. Preparation of hydrobromic acid. The constant boiling mixture of hydrobromic acid and water can be conveniently used to prepare alkyl bromides. The acid boils at 126 degrees, contains about 47.5% of hydrogen bromide, and has a specific gravity of about 1.48. The acid can be prepared from potassium bromide or from bromine. From potassium bromide, in a 215 centiliter distilling flask, pour slowly into 85 centiliters of water and 98 grams of pure concentrated sulfuric acid. To the mixture, add 119 grams of powdered potassium bromide and distill slowly using a water jacketed condenser. Collect the fraction, boiling at 125 degrees, 126 degrees. The yield in 18.5 to 19% of the theoretical. From bromine, in a 200 centiliter distilling flask, place 162 centiliters of water and 10 grams of red phosphorus. Cover the side arm of the flask with a cork. Connect the flask with a return condenser and place it in a water bath so that it is completely covered with cold water. Put 14 centiliters of bromine in a small separatory funnel and support the latter in the condenser at top. Allow the bromine to flow into the flask slowly, drop by drop. When all the bromine has been added, support the flask on a wire gauze, connect it with a condenser and distill. Collect the part which boils at 124-126 degrees. The yield is about 95% of the theoretical. Preparation of hydroidic acid. The constant boiling aqueous solution of hydroidic acid can be conveniently used for the preparation of alkali iodides. The solution contains about 57% of hydroidic acid, boils at 170 degrees, and has a specific gravity of 1.168 to 1.17. The exact composition varies with the pressure at which the acid is distilled. The solution is prepared as follows. In a 100 centiliter distilling flask, place 16.5 centiliters of water and 70 grams of iodine. Put the flask in a water bath containing cold water and force it down so that the whole bulb of the flask is submerged. Hold the flask in place by means of a clamp and a ring stand. Add 6.5 grams of red phosphorus. Let the flask stand for about 5 minutes. Support it on a wire gauze, connect with the condenser and distill. Collect what boils at 126-107 degrees. The heat is about 95% of the theoretical.